Hello everyone, welcome to another episode of your weekly dose of Terraform. And today we have a kind of special episode because I want to talk about serverless.tf project in a little bit more detail. For those who don't know, I will try to explain why this project has started, what exactly it is, and we'll see how it goes. So yeah, let's get started. As soon as I figure out how to share my screen again, here we are. So N0, for those who don't know, is sponsoring this episode, and they have recently published the blog post about how to run Chekhov and N0. I have had an interview with Barak, who is CTO of Chekhov, or CTO of company behind Chekhov, which is called Bridge Crew. And you can take a look on this blog post and see how Chekhov can be incorporated inside of your CI/CD pipeline running on N0. It's pretty straightforward, but it is something where we all should be moving with different speed, with different goals. But anyway, here is it. If you want to give it a try, please go to n0.com/Anton and you will see how it works. Well, this episode actually is almost kind of related to my talk, which I'm gonna to give next week, and it's gonna to be Hashi talks. So it's like 48 hours of kind of non-stop talks about all kind of things related to HashiCorp products and a bunch of interesting things here. I'm specifically interested in this one, Pluralit, by Daniel. I will just show what is it in a second. And there are a lot of other things which I usually pay attention, and I really like to see what other people are doing. So feel free to go to events.hashicorp.com, and you will see the link there, and you can register for free and then find talk and go and watch it. My talk will be 8 o'clock GMT, but it says February 17. Well, it's actually February 18. Anyway, it's February 18, 17 and 18. It's a lot of things, a lot of interesting things, and discussion will be on YouTube as well. So when we have this thing out of the way, let's, what else can we do? Well, yeah, of course. Let me just say big thanks to people who support my work. And well, there are a few people who decided to stay private. They are private sponsors, so they joined recently. So thanks a lot. You guys support me, and it's really important for me. I think this week 1 or 2 private sponsors joined, and also Andrei from Czech. If you guys are looking into kind of educating yourself and you want to learn some of technologies which he is teaching, feel free to check out his courses. He's doing Docker, Kubernetes, Terraform, Rancher, and a bunch of other things which, well, we all have to know with different level of degree. But anyway, feel free to check him out, and yeah, that's it. Okay. And actually, serverless.tf, which I'm gonna to be talking about today, is already in use by some of my current existing sponsors, and also a few companies primarily located in Asia. I don't know why. I don't know how it's related, but I think most companies or most users of serverless.tf and Lambda module are actually from Asia. I don't know why. So anyway, nevertheless, hello Sven, and thanks for support. And let's get going. Also this week, Mike, who is also from Oslo, where I'm based, he asked me if I can go a little deeper and explain how serverless works with EFS. So that's going to be the primary focus on actually what I'm going to do live coding today. But before I go deeper into live coding, and let me explain what is actually all of this about. Okay, so for those who don't know what is AWS serverless approach, and what is Lambda, and what is API gateway, and some other services, unfortunately I don't have time to explain all of this and why serverless is cool, where you should use it, and all this kind of stuff. You can always go to AWS Amazon.com and then serverless. Yeah, so here AWS explaining what is serverless, and it's really good explanation of how things are interpreted by AWS. Just for everyone to be aware that there are a lot of services available. As you can see, they're listed here. How you can describe a bunch of different infrastructure resources, it's totally up to you. Okay, so what is actually serverless.tf? Well, first of all, this project has started with an idea that there were a lot of interesting challenges which I don't want to even fix. All I want to do is just to get my job done, which on that time when I was working on it project, when I was researching, and when I was struggling with existing solution, I figured out that I spent significantly large amount of time doing things which are not related to business value which I was trying to develop. So, and then I looked into existing solution. I've been using serverless framework for at least 2-3 years, not very heavily, but still I get the point. And if you can understand what I'm going to explain, you maybe have the same feeling. So imagine the situation that you have, let's say, one project which lives on its own, but from time to time you have to fix some things. And you don't work on it daily, you don't work even weekly on this project. And when you have to do some work, then you kind of switch focus to that project, you run npm update, because hey, there was new dependency released during this time when you didn't work, and you realize that now you have to go deep into rabbit hole and actually fix a lot of things which became incompatible, or you have to review changelog, or you had to write some JavaScript code, or you actually have to do a lot of things related to maintaining of serverless YAML config file, because it's all in one file or in multiple files. It's up to you. The point is that you are not actually spending time which you wanted to spend on actually fixing bugs and to go back to another project where you're supposed to work. And I understand myself that I spent significant amount of time just maintaining things which were absolutely not related to what. And this is what I call to accidental complexity. Well, this tool was given to us because there are not many alternatives available. So, and tool was evolving constantly. Even now, when I go to serverless framework documentation, it's big and it's not very up to date, and it's rather hard to keep up if you are not doing it absolutely full time. So, what other thing we were doing before is that we had pretty clear separation between different tools. So, serverless application frameworks were supposed to help us with writing code, with updating infrastructure. CloudFormation is behind, so we have to do sometimes some hacks here and there. Anyway, it was pretty much doable, and a lot of people are using it and happy with it. But at the same time, we see a pretty large amount of people who are using Terraform, and they're also quite happy because they need to do infrastructure management not related to serverless as such. For example, there is database, or there is a queue, or there is some sort of other resource, or there is network, which is not related to serverless as such, but it's already inside of Terraform. Okay, so we have second group. And then we have to have some sort of glue, which actually shell script, makefile, code deploy, CLI, and you name it. Okay, so a bunch of things which call different things, which pass different parameters. That's what we have to struggle. What I was thinking is like, why do we have to split this if we are quite happy, well, at least I am quite happy with the way how Terraform works, and I can use it with TerraGrant or without TerraGrant, but all I want to do is just to have a really comprehensive infrastructure management solution for everything related to my infrastructure and to my serverless application. I will show what exactly it means. The key point here is that there are dependencies between different resources, and that's exactly where we have to be able to tell Terraform that, hey, please go and figure out what exactly has to be changed in all of our infrastructure, or in a subset of infrastructure if you're using TerraGrant. The point is that we trust Terraform to resolve these dependencies for us, and we just keep using it. Terraform apply, Terraform plan. We already have some sort of CI tool which we can utilize for that, and Zero can run TerraGrant and Terraform natively, by the way. So that was first point, which was pretty critical for me. And second thing is, when I asked people, okay, we have some sort of separation between serverless resources and traditional resources. If we look into documentation by AWS, we can see that they say serverless services on AWS. Cool, we have Lambda, we have Fargate, we have this and that, and a bunch of other things. But what about VPC? What about some services which we were using historically before even term serverless came up? Well, we think that this is not part of serverless as such. Okay, so then we need to do something different. Then now we need to think about, okay, this is going to be serverless resource like API gateway. Then we manage it as a part of application framework. Or if it is IAM role or VPC or S3 bucket, then it is infrastructure management tool. Well, that's a little bit confusing to me. Now I have to think about where this resource is going to be used, who is going to have access to it, and so on. Okay. Well, I think coffee is a good idea anyway. Hopefully I don't smash this cup of coffee in front of me, as it has happened sometimes. Okay, let's move on to another approach. A rather slow application development lifecycle. Do you remember yourself running something, well, SLS deploy, or Chalice, not Chalice, but Zappa deploy, or any other things? So what has happened? First, your application was building, then it generates CloudFormation template, then you rely on CloudFormation to do the actual heavy lifting, and you usually see it without understanding what's going on, or just dots appear on your screen and you see like, okay, if there are more than 20 dots on my screen, then something is going to fail most likely. But you don't know until timeout, and you have to sit and wait for that. So that was really frustrating most of the times for me, especially if there was a bug somewhere inside of JavaScript library which was used to manage some sort of infrastructure component, and that was really challenging to figure out until you run it, and then you wait, and then you see, oh, okay, that's an error, and then you go and Google for it. So overall, it was a little bit challenging for me to, not even challenging, but hard to understand why, in order to manage, let's say AppSync. Okay, AppSync is a GraphQL managed service by AWS. Why, in order to use AppSync, I have to do anything else than just calling Terraform AWS provider and give a bunch of parameters to it, and that's it? Why I should even use JavaScript code, which is doing everything what Terraform already does for me? I mean, calling SDK and creating and managing this resource. So I was a little bit frustrated when I even look into that. And those solutions are rather popular. Well, at least they have stars. And I don't know why they have so many stars, honestly. Maybe that's because people don't want to lose them. But in most cases, I think that the point here is that we don't need to know what is actually inside of the solution in order to use it. And that's extremely often when I see it with my customers as well as in open source in general. So yeah, that was kind of description of why this has even started. And as you know, there are a lot of Terraform AWS modules, which I can go to GitHub. And well, there are step functions, VPC, and RDS, and many other, pretty much for all solutions. So AWS Lambda is the one which I'm going to show in a second. So as I was looking into supported AWS serverless platform services, so even when I started making this page, I was thinking like, okay, I definitely have a lot of components already. I mean, I had a lot of components which are commonly used even without word serverless, like S3 bucket, Dynamodb table, and so on. So these components I had before. So there are modules which we can use and they do certain things. But the interesting, like the main component in all of this is definitely AWS Lambda. And the complexity which kind of has, or which is inside of AWS Lambda, is pretty big. Is definitely one of the most complicated module which is actually in use. I mean, there is also pricing module, but it's not so much in use. I have been talking about it for the last 4 episodes. So AWS Lambda module is definitely one of the biggest thing because it's really complex, and I will show it really in more detail. So yeah, a bunch of different services which are listed on this, on this, well, somewhere here. I guess maybe they changed this page somewhere, but anyway, most of these services which we can see here, they are managed by AWS, and that's why they are listed here. So I have been trying to figure out how to make these modules kind of reusable for step functions, for AppSync, for CloudFront, for Lambdas, and so on. So yeah, that's pretty much a short explanation about why this thing was created. And if I click on this link and go to documentation, here I describe a little bit more detailed approach, pretty much what I just explained. I guess I didn't read this document for almost a year, but it's really hard for me to imagine something new. The point is that, well, what's the point here? It's just describing a lot of things which I just covered, actually. Another prominent kind of solution, which I personally like quite much, is serverless application model. But it's not quite there yet to be extremely useful, especially for people who use Terraform already. So currently I can see that there is not enough kind of integration between AWS and Terraform. I mean, there is some things, but it's rather limited. And that's why we have to come up with solution like serverless.tf or some different modules, or write in some glue code somewhere in between, though it shouldn't be like this to my mind. And the complexity of Lambda module preferably should not be in the module itself, but should be inside of provider. And we just tell, hey, please make this stuff for us, and it should do this. Okay, so, well, let's see. Yeah, if you like any of these projects, never hesitate to click star and share it. It really helps me to figure out what kind of things people like or dislike. Well, there is no button to dislike, but if you don't click anything, then I imagine that you dislike it. Okay, let's go let's go deeper to the code. So what I'm going to do today, I want to show a couple things. So first of all, here is serverless.tf playground repository, which is actually in my account. It's somewhere here. So it's github.com/AntonBabenko serverless.tf playground. And this code is kind of working, but since it's playground, I want to add some new things. It's not showing how things should be used in production, but it's more showing different features like as a whole. Okay, so let's go back to the code. Here we are. So this folder, serverless.tf playground, is exactly as I just showed. What I'm going to do here, I'm going to look into different files, and then I'm going to try to add required things related to Elastic file system, so that Lambda function will be placed inside of VPC, and it will have support, or it will have Elastic file system attached to it. So I have not created this code kind of completely before, but before the stream I copied some files from different projects into this one, so it's going to be live coding. I mean, otherwise there is no point for me to show it, right? Okay, so starting from the project itself, what I have here, I have pretty much two folders. One folder is src, where I pretend that I have my Python code, and this is going to be my Lambda function, which, well, you can see that it doesn't do much than hello and then just showing a couple JSON strings and returning this output. So pretty simple stuff. I also have Go function, but I don't want to go into details of how to do this for Go, because Python is a little bit easier for me right now on this computer. So also there is another folder called modules, where I put code which creates Elastic file system, resources. I copied this code from another module. It's probably not very clean and not very elegant, but for the purpose of this stream, it should be all right. And the main code is inside Terraform folder, where I had before different things related to provider, instantiation, code deploy resource being created, and then I create Lambda function with different configurations, and then I create an alias for this function, and then I create, as you can imagine, I'm creating Dynamodb table with certain properties. Then I create AppSync just for fun, because there is module for that, and well, and that's it. And then I create API gateway. As you can see, it's a little bit early, so that's why it says 0.0 here, but in fact it can be it is pretty much stable already. There are a few things which still can be added. For example, later today I'm planning to add authorization support, as some people have actually created pull requests, and I will just review it and merge it. So that's pretty much it. So here we are creating API gateway of HTTP type with certain properties, and that's it. The cool part here in all of Terraform AWS modules is that they are pretty stable, so that you can actually use all of them, and you can easily connect them like together. For example, if you want to make an API gateway and you want to add Amazon Certificate Manager service, like certificate by ACM, then you can call another module which is called ACM and pass arguments to API gateway, and then it will create API domain name for that and connect things together. For most of these things, there is already code available inside of well, API gateway module. So you can go to API Gateway module inside of GitHub, and then you can go here, and you should be able to find some code here. Like here we are creating ACM, as you can see. And so we are creating certificate, we are connecting this API gateway to Route 53, and we tell to use this certificate inside of the main name. So this is in use, and this has been available since initial release of this module, which I think I did about half a year ago. So going back to this Terraform folder, what else is interesting here? Oh yeah, off topic. Let's see. Hello Artyom. Sorry for the off top. What is the right way to break down state with all resources on it? Monolith repo into smaller parts, micro repos with their own states, EC2 lambdas. Well, it's kind of a huge question, as you can imagine, but in general, try to make things as small as possible is still the preferred way by the majority of people. I remember, I think this week or last week, there was discussion at Cloud Posse about how to organize this stuff, but the outcome for that was usually try to figure out what is the smallest thing which makes sense to you. Like, for example, in terms of Lambda, or in terms of actually everything, for me, the smallest thing is one module. So if you have like some EC2 instances and some Lambdas and some RDS, then most likely your Lambda stuff will contain of many things related to not just one resource which is called Lambda, but also it will be Lambda function. It will be probably where is it? Lambda permission. Also, it will be related to a bunch of IAM policy, IAM role, and so on. So this is going to be one thing. And the solution is that once you, the reasoning for that is that once you have everything wrapped as module and you have one state per module, it will be extremely easy for you to transition to TerraGrant. As I understand, you want to make Terraform plan faster and move to TerraGrant. So yeah, that's definitely possible to do. So that's why when I look into TerraGrant code, when I look into Terraform code and it is containing mass like this one, this is not good project. This one here is not good project structure because it creates everything. And now you will see that plan will take a lot of time because a lot of different resources will be created. So this is bad structure. But again, this is playground, so that's why I'm not showing good structure. Good structure would look a little bit separated. So I would have some sort of VPC resources, some sort of EFS resources, some Dynamodb, and then I will have lambdas, like many different lambdas. All of them will call just one module. So this module will be called. Yeah, I think that's pretty much it, what I can say. Okay, so let's go back to this stuff. Right, so what I have here, creation of different resources, API gateway, app sync, and so on. S3 bucket, also just one module called to create bucket with specific name. It should be private, and as somebody pointed out, this is pretty good saving, not saving, but pretty good safety net, so that you can specify block public ACL true, and that's it. And then inside of the module, it takes care of what is actually gonna to happen, how it will restrict public access, and so on. It's gonna to happen on S3 bucket level. So let's do some coding. I hope I have explained how things work right now. So right before this stream, what I did, I ran Terraform apply. I have created, hopefully you can read this green on white. I think it's not very interesting to read such strange colors, but unfortunately I don't know how to make theme perfect. So here we are. If I run Terraform apply, it now tells that everything is created, and here you can see all resources like API gateway, app sync, and Lambda functions. Everything is created. So that was before. Now let's do some addition. Let's do. I will show what exactly I'm gonna to add. So here I have Lambda function, which currently is not deployed inside of VPC, and no EFS is attached. Let's look into what kind of arguments are specified here. So quite obviously, you have to specify a few required arguments like function name, handler, runtime. These are pretty straightforward things. But also Lambda module have possibility to create pretty much all other resources as well. For example, if we look into Lambda module examples, and then if you look into complete, because complete is complete, then here you can see that there are few different configurations how things can be done. For example, Lambda function can have different layers. You can decide that you take source from this path and you want to store a produced artifact inside of S3 bucket, which is here. You pass different environment variables and few other things, of course. But also, I think this module does a little bit too much. Maybe it's like, I don't know actually what else to add here in terms of how different IAM policies can be managed. So you have one Lambda function, and you have option where you want to handle IAM policy, IAM role attached to this Lambda function. By default, you want to manage it inside of this module. But if you want to manage your IAM role somewhere outside of the module, you can obviously do this. What is really complicated here is how you can add different additional policy. So you can specify it inline. You can specify list of these policies inline. You can specify IRN. You can specify list of IRNs. You can specify statements implicitly, and I think that's all. So, which means that you have absolutely control of how IAM role for this function will be created. And this is only applicable when you create function, while this module also has support to create Lambda layers, which means that create layer equal true, and you just specify how to call this layer and where to get this source from. Again, imagine that when you need to create Lambda function, that's pretty much all what you need to write. You say that, hey, call this module, which should be Terraform AWS modules, Lambda. Then you specify that create layer equal true, give layer name, and tell which runtime it's compatible with, and where to get source. That's it. There is no other things involved. The rest of this is handled by the module, and you have control to control everything, but most likely you don't need. The same here is that if you want to handle, if you want to create Lambda layers, but you want to keep the packaged version of it inside of S3 bucket, you can do so as well. So as well as Lambda at edge, provision concurrency, and many other things which you probably need at some point. Again, I was trying to think about different combinations. And here are other supported examples, like with how to do this with VPC. Well, I actually can take this example as well, but I think it should be fine. Oh well, that's actually easy. Let's do this one, right? I mean, I don't need to call the whole module to make just VPC and attach it. to EFS. So yeah, I will take this example. It's going to be much faster. Okay, let's take this file. It's going to be much simpler than me writing this file from scratch here. Okay, so now when I explained what I have here inside of Terraform folder, let's look into what exactly has to be added. So I will have this Lambda function inside of this location, and it will do the same things as before, but I will also add another function which will be just having access to EFS, and for that one I put it inside of EFS. Okay, so this one is not needed. While it's actually kind of interesting point, let me show it just not here, inside of main. Yeah. For those who saw some of my previous code, I usually put these 5 exceptions or 5 skip arguments inside of provider blocks. The point is that it will just make your execution faster in 99% of cases, because you are not going to produce unnecessary API calls. So that you skip EC2 plus for metadata, region validation, and all this stuff is not necessary in most cases. Anyway, Terraform will fail if something is missing. For example, if you provide incorrect region, it will fail anyway. So that's not necessary to provide, and again, it's just faster. While working with serverless, this one is quite important, is that skip request and account IDs equal false is important, because like if you enable it, if you say true, then it will produce invalid IRN for your API gateway. So if you see that your API gateway is not right, then just verify that you have the skip request and account ID equal false. And that's pretty much it. There is not much what I want to say about it. Okay, so let's see what I have here. I have EFS, and for that one, what I do have, I have random path this, so I don't need this. Well, I don't need anything here actually. So this function will be residing inside of this file. So let's see, Terraform AWS modules Lambda AWS. Occasionally I need to specify something here, but it's not required. Again, for this demo, usually you have to specify it quite carefully here. So function name is going to be Lambda in VPC with EFS. Description, my awesome Lambda function in VPC with EFS. Well, I don't know what kind of source I used. So it means that I'm using local path here. Usually when you have different, like when you have a lot of developers and you have source laying in one place, you have to avoid using absolute path here. So make sure that you just agree between yourself that we have certain structure, and this will save you a lot of time. Okay. So what else is interesting here? Intra subnet. Okay, I will look into module VPC. So module VPC says that we are going to create just one VPC with one intra subnet. So module VPC has 4. Well, I don't even remember how many types of subnet it has. The point is that you have most commonly used it's public, where you have access to resources inside of public and access outside. Then you have private subnet, where your resources residing inside of private subnet can go to the internet through NAT gateway, but nothing can reach them because they're in private subnet. And then another type of subnet is called intra, where your resources inside of intra subnet cannot access internet because there is no NAT gateway attached, and obviously nothing can reach them because there is no internet gateway attached. So this is usually preferred scenario for your Lambda functions, because your Lambda function will be staying behind some sort of API gateway anyway. So let's see. So that's pretty much it. And now the interesting part about EFS. Again, this code is much simpler than the one which I have inside of EFS here, because this was actually a module, which means that I can quite easily reuse it for different configurations, for different side of Elastic file system, access points, and many other things. Again, for this demo, there is no need to do that. So what we are going to do here, we are creating Elastic file system, and then inside of that file system, I'm going to use default security group just because it exists. If I would want, then I have to create another security group, specify that that security group has port 2049 open for the specific CIDR blocks or for the specific security groups, but for this demo it's not needed. And then I specify one EFS access point and specify who exactly can access certain paths. Once I have that Elastic file system created, then it is going to be used as an argument in file system IRN here, where I say that /mnt shared storage is going to be pointing to this one. Yeah, so it's going to be /lambda inside of that file system. So that's pretty much it. There is no rocket science involved in this phase. The rocket science will be necessary if you want to control different access permissions to EFS. But as I said, for that one, you will have to make your own security group, and you will have to control who has access to it. Like in this case, wait, where is it? I had it somewhere, not here, maybe, well, no, it's not here anymore. Yeah, we don't need this VPC stuff again. So that's pretty much it. Interesting part here is that attached network policy equal true is an argument of Lambda module, which means that, well, I can probably show it inside of source code. Inside of this one, which means that AWS Lambda Elastic Network Interface Management Access will be attached to this Lambda function. And usually, as far as I remember, this is enough to have proper access. Yes, this is enough. This hasn't been changed for quite some time. It's actually quite interesting is that recently I have received few emails from AWS telling that they are refactoring or they do some changes inside of IAM policies, and they rename some policies. They change name for different reasons. Hello, Mike. So yeah, that's pretty much it. Attached network policy. There are many other arguments which you control in this module. For example, if you are using dead letter queue, you can specify that you want to attach dead letter queue as well. as well as X-ray is attached tracing policy, async event policy, and many other things. All of this is inside of examples, as you can imagine. So let's go back to this EFS. So what I can do now is, if I run, I think this code looks pretty good. The last point here is this one, explicitly declare dependency. Well, I'm using Terraform so much that I actually not a big expert of all of this depends on, because Terraform allows me to simply wait anyway. So there is no need for me to think about depends between modules. While with Terraform, this is quite often the best solution which you can get. So if I now run Terraform init, and it will download VPC module and maybe something else. Previously reusing, that's pretty cool. So now if I run apply, now let's see, it should be working because I copied pretty much everything from example. That's cool part of example is actually I spent significant amount of time writing examples, thinking about different edge cases and so on. So that's why I'm quite confident that if there is example and it works, then there is nothing else what I should be worried about. Okay, so here we can see that 16 resources are being created, and I think it's quite interesting to explain how things are actually work inside of Lambda module. So let me just verify with eyes how things look like. So we're creating access point, file system, mount. That's pretty straightforward. And then we are going deeper inside of Lambda function module, and it's just creating a few things here and there. That's pretty much no-brainer for this part. This is where the magic starts. As you can see, it's using Python 3 with this package py and prepare. What it means is that this this source code is going to be built, how to explain even, so this source code is going to be built only in time when it is necessary. So this is again one of the important difference of Lambda module versus some other solutions which, well, not some other, but actually all solutions which I know, people are not deferring when exactly to produce archive. In most cases, people don't worry that if I run Terraform plan, then file is created. For me, this is not correct. I run Terraform plan always with a guarantee that no files are going to be created, nothing will be updated. It's absolutely safe to run multiple times on any environment. While if you use data source archive file, it will create file for you in run phase of the execution. For me, that's just unacceptable. That's why we are using package py to prepare and to figure out what exactly is going to be created based on this configuration. So based on this configuration, for these arguments, for this source path, we are going to do what we want to do. Well, let's see. Yes, one thing as you may see here is this is quoted, like not quoted but escaped. This is related to the bug inside of TerraGrant, where, I mean, I know that I'm not using TerraGrant right now, but the point here is that if you pass, I mean, that's really a complicated thing, but I think this is helpful if you're gonna to learn something from today's stream, then it should be this one. Let me see, it's called source path, right? So when you have variable of type any, then TerraGrant will not, well, I forgot the reason, but then TerraGrant will not escape this value properly when passing it to Terraform. And the reason for that is that Terraform is not able to understand it. So simply speaking, if I would use the same code inside of TerraGrant, it would not work. It would simply say source path is empty. That's because type is any, and Terraform TerraGrant relation is not perfect. That's why I know that it's any, but I make it to look as a string always. So if I specify some other type, for example, I want to build several sources at once, or I want to build from different structure like list of string or map of any. There are use cases for that I can show in a bit. TerraGrant would not be able to pass this information to Terraform, and this took quite a lot of time for us to figure out why this was a problem. Here is another solution, or another more complicated example, which I took from a real project where I use this. So here you can see source path, JSON encode. So and here I use list. That's because I want to sometimes I want to build from group of this. For example, I can do something like this. What it means is that source path for this Lambda function will be that it will take code from this path and it will apply these patterns. So it will remove all things related to tests and a bunch of other things, and it will kind of connect this result with another result. So if I have, let's say, several functions where runner 1, runner 2, runner 3, then I can pass it as a list. And that's exactly where I need to specify JSON encode, because it would not work. So this one is not going to work with TerraGrant. There is an open issue, but as far as I remember, it's not going to be solved in any near future anytime. So once more, if you have variable type any, make sure that your inputs from TerraGrant HCL file is JSON encode. This is going to be much easier solution. While some people say like, oh yeah, why don't you want to make this as more predictable type instead of any? And the answer to that is that I don't want to give multiple of these. For example, I can make source path string, source path list. That's not so elegant. I don't want people to know that there are difficulties between Terraform, TerraGrant. So all I want to tell them is that, hey, tell me absolute path to a local where this stuff has to be built. And that's working like quite nicely. Okay. So let's see. I revert many things back. Right, okay. So what else is going on here? Yeah, another important argument is that like in this case, I'm planning to deploy this infrastructure, this Lambda function. So that's why archive prepare is evaluating what exactly is gonna to happen. It's not creating files yet. It's just planning, and it does so by checking whether this file name actually exists already in the correct location or not. Here I can specify artifacts directory, like in this case it's builds, this is default location. So there is a folder called builds where files are. If I would specify this as a S3 location, then it would be checking whether this file exists somewhere else, and so on. What else is here? We're creating kind of predictable things here: CloudWatch resources, IAM policies, and roles, and Lambda function itself. So Lambda function itself has package type zip, but as you may know, there is a way to create Lambda functions using ECR, Elastic Container Registry, and using another package type which is called image. I think it's really awesome, and I have created example how to do all of this as single Terraform apply. If you are interested in that, you can go to Terraform AWS Lambda, examples, and then container image, and this is implemented here. We're creating Lambda function using this image URI, sorry, and here I specify that I use Docker provider for that, and some other things. It's really easy. As you can see, this is all what you need to do to create image, to push it to registry, and then you use this as a reference. So that's pretty much it. Important here is that you specify that you don't want to create package using Lambda function module because you create it outside. That's it. I think this is really a interesting solution if you don't want to do pretty much anything except just building images somewhere else using your own CI and then just deploying them. So here how you can do this. Okay, let's go back. So we are almost there in this plan. What else is interesting here? Well, yeah, and one file which is going to be created is called archive plan. This file looks like, let me show how it looks like. It's a JSON file which contains information about key points which are important to identify the content. So there is no content as such, there are just references. Like all of this were combined together to come up into this SHA. So once I have this SHA, then I can identify that this file exists or not exist. Again, this file will be created. It's not yet created. And then we're creating very simple VPC with just one subnet. Let's see. So if I run yes now, it should work. Again, this VPC is so simple, there is no internet access to it because it's an intra subnet, and we are creating some file system. Very basic file system, I have to say. In most cases, configuration for file system looks like this. No, not like this. Okay. Anyway, let's wait for it to run. Here is another interesting part which is missing in the example, but in practice, it's kind of useful. Is that I want to specify that my Lambda function, which is going to be created soon, has access to Elastic file system. That Lambda function itself can mount, can write, and this is possible to specify as an argument. So if I just do like this, and I put it into this one, so then it will be a little bit more complete. So I create Lambda function, Elastic file system, and I also need to tell that, hey, this Lambda function, you are awesome, but you need to have access to Elastic file system. So we do this like this. We don't need client root access, though sometimes I use it for some really short-term development. And resources here, I copied it from Terragrant, so I need to figure out EFS output IRN, which is probably this one, and values access point IRN. Well, access point IRN is this one. So it's going to be this lambda IRN. Yeah, that was it. Let's see it. Well, yeah, it should be soon done. So this is not needed. I sometimes put some references for myself when I develop something, but then I forget to remove them because I think that they belong here so organically that, like in this case, it's like, hey, how to do this stuff with IAM authorization? Here you are, you click on this link. Well, anyway. So attach policy statements through will just create couple IAM resources, and yeah, it will be EFS outputs IRN, and this is access point IRN. Okay, so it should be access points EFS file system, right? Outputs IRN, what is it? Sometimes when I don't know what was the connection between this one, like this one, and TerraGrant, I need to go to source code of the module to figure out what was actually IRN. IRN was elastic file system. Okay, so it was this resource, shared IRN, and condition is elastic file system access points. Well, yeah, it takes some time because VPC and elastic file system are not the fastest resource to provision, but it should be pretty straightforward. Another slow resource to provision is related to provision concurrent executions. So here, if I specify 10, then yeah, it will take I don't know, maybe 2, 3, 5 minutes to configure that. It's not related to the number. So if I specify this one, it still takes the same time. Okay, so if there are questions, please let me know. So yes, as you can see, it just created all this stuff for me. And if I now run apply one more time, I want to see a couple more resources to be created and attached to Lambda itself. As you can see, plan is not very fast already. EKS is longest one. Yeah, right. EKS is definitely not the fastest, I would say, but at the same time, when I work locally, I often get try to optimize my environment so that I can run things as granular as possible to figure out how things are working together. So 2-3 minutes every time is really a long time. But yeah, EKS, that's not something what I work at all. I have never worked with EKS and EKS module. So, okay, so now I have created this stuff. What has happened? Well, if I go to console, it will obviously be there. So yeah, this is kind of the last thing which I want to show. As you can see, it's quite easy to describe Lambda function with bunch of standard resources, some VPC resources, or VPC properties of this Lambda function, elastic file system properties, and a lot of different IAM policies are also available here. There is a demo for all of these statements inside of examples, and you can always go there and see how things are supposed to be configured. So yeah, one last thing which I want to show, it's kind of not related to this module I don't need anymore. So this is here. well, you may think that Terraform is good for... Yeah, you're welcome, Mike. You know where to find me. Okay, so if you know that Terraform can describe infrastructure, that's kind of obvious, right? But what Terraform can also do is that Terraform can create items inside of Dynamodb table. And this is an example of how this can be done. So I am here inside of Dynamodb data importer. Here I'm quite interesting things here is this is standard, and then I'm calling that data source because I want to get information about Dynamodb table. And if I run this example now, let me run it and you'll see what I mean. Of course it fails because there is no Terraform in it. So let's see if I run apply now. Let's see what is going to happen. Right, so it's going to create a couple resources. This random path is just name, and then this random path is going to be inserted inside of table which I have created in folder Terraform, because that's part of my serverless infrastructure. So what I want to do is that I want to add a new item inside of my table. So if I say yes and wait for a second, it says that this item has been added. So glorious lion has been added into this Dynamodb table. I'm quite happy. But what if I want to run it again? Well, I can do this. I can do this quite infinitely, I think. So if I run it again, the worst thing that it can fail with some kind of 400 error after long time creation. Well, everything can fail with 400 errors. And that's, let me think. Well, actually quite interesting. When we are talking about simple resources, like I had a customer this week or last week talking about issues like AWS EC2 instance is a simple resource. Oh yeah, it is simple until you hit limits of Terraform module inclusion, because module in module in module with for each in between is not good solution, and Terraform doesn't know what to do with it. So there is obviously always use case for something, but as I was trying to explain to people, try to write something as simple as possible, as linear as possible. Don't use all crazy features of Terraform, especially in terms of for each and count. There are still a lot of bugs. For example, the bug which I'm referring is reproducible only when you have more than 100 AWS EC2 instances to be created. Not when you create 50, but only 100, 120, and so on. So that's exactly the bug which you cannot reproduce so easily, but yes, it is there. So errors like 400 will happen, and you just cannot do much about it. So here you can see that another decent we will, well, I don't even know what does this animal mean. Let me Google it. Luckily I have dictionary available, so we will, oh my god, долгоносик. In Russian it's animal with long nose. Well, no, it's not. It's kind of small insect as far as I remember. Anyway, we will. So yeah, we will. Pretty interesting. Like, we will talk tomorrow. Okay, anyway, so here I'm reading from data source, and this is the interesting part. Why it is interesting? It is interesting because I don't care what is inside of the database. All I want to do is that I just want to keep pushing to my awesome Dynamodb table. So what is it? Approve? Well, no, it's not approve. How to write it? Approve. auto approve, right? Right. So all I want to do is just want to run this Terraform apply auto approve and create a lot of different records. So the cool part is that there are situations when you want to create infrastructure with Terraform, and then you want to do, let's say, call AWS CLI because you need to populate some data, or you need to let's say create archive or extract some archive or do something about it. For specific things like that, if it is not, if you don't try to make it look extreme, then Dynamodb is a good example. You can use something like Terraform backend in mem, because you just don't care about it. So if I comment out, as you can see, there is no Terraform TF state. So that's the cool part, because it was in memory. That's why it never tracked status of records, and it was always insert a new one. So if I go to run, I need to run init because I have changed backend configuration, and it says that successfully unset. So now it will be using local remote state or local Terraform state. And now if I run Terraform apply or auto approve, doesn't matter, we will see that there is file Terraform TF state being created. Here is it. And we can see that viable arachnid, well, I think I will soon learn English if I follow. Oh my god, it's insect. This is synonym for insect. Anyway, if I go to Terraform TF state, then I can see that my viable arachnid is here. And now if I run Terraform apply, it will not insert anything because nothing has changed, right? And that's not what I want. I mean, what it will do, I don't know what it will do, but one changed. Yeah, so anyway, the point is that it's still using the same item. There is nothing else. There is always viable arachnid all the time. So yeah, that was pretty much it. But try to not use backend in memory for real things. Only if you want to do small things, just because you cannot do it in other ways. Okay, so I think that was it for today. I have tried to explain how things work. If you have more specific questions, please let me know. But yeah, feel free to feel free to go to serverless.tf playground, or if you want, give a star to serverless.tf project. And yeah, I think that's it. I don't have anything else planned for today. Just thanks everyone for attending, and see you next time. If you have any specific proposals, you know how to find me. Well, if you don't know how to find me, I can tell you. You go to Twitter /Anton Babenko, and you can talk to me there, or you can reach out to me on LinkedIn, which is also Anton Babenko. 400 definitely can happen. Okay, there is a question, or not question, probably comment by Artyom. 400 definitely can happen, but what is annoying that you will not get this error immediately after you run apply. It can happen after being in status creating for 5 minutes. Well, there are a lot of situations like this, honestly. I don't know exactly, like I didn't hit this problem myself, but it can happen by variety of reasons. It's yeah, so I don't even know where to kind of to uh, to start answering. So yeah, 400, 500 happens. Terraform retry will do its best, but it will fail if you use, as I said, multiple modules included into each one with for each. Um, if you don't hit some limit, try to increase number of resources. You will be eventually throttled by some of AWS systems. Okay, question. Lambda you mentioned in your code run Docker container, correct? No, it doesn't run Docker. Let me show it. Let me show. Where is it? Here is it. Okay, so the module which I was talking about, so AWS Lambda, is just Terraform files, and it uses Python to do heavy lifting. So this heavy lifting is specifically related to the lack of functionality which is inside of Terraform. So that's why we need to do some crazy things related to verifying whether this file will be created or whether this file actually exists, or what should be placed inside of that file, how to respect different regex expressions to exclude certain type of files, and so on. We generate content hashed based on the values of the files which should be included. Again, ideally, all I wanted to do, like if I can change my mind, instead of all of this, all I wanted to do, and that's actually what many people do, all I want to do is just this. I say that, hey, this is output file, and I want some content. Where is it? Source. And I want to specify, please make archive from these things, right? From this different type of sources. But this produce archive in runtime, and it doesn't respect a lot of things. Like you cannot exclude files, you cannot verify files. So that's why all of this magic, including Python Py, is implemented. But things related to Docker, that's which I was talking about, is inside of container image. So what's going on here is here we are creating Lambda function itself, and I'm using Docker provider, which is this one. So I actually mentioned this provider a couple times already. This provider is taking care of various Docker commands, and what it does is that it will create this Docker image from this context. So this is context for the Docker image. As you can see, it's copying some files from scratch, and it will create this Docker image, and it will also log in to this ECR address. So I'm creating a repository, I'm logging into this repository using temporary ECR authorization token credentials, and I'm pushing this Docker registry image to this ECR. So that's what is going on here. Overall, this solution is working extremely simple and extremely straightforward. Obviously, if you need to use some complicated things, like for example, you need to do some things which are not supported by the provider, most likely you cannot use it. Then you will have to do a two-steps process. First, you build your image, you push it to ECR, and then you discover this image and you pass this image URI here as an argument to this module. But I have to say that this Docker registry image, let me show it in registry Docker, this one. So this one is extremely big thing. So if you look into documentation, and if you look into this resource registry image, here you are. You have pretty simple thing, right? You have, that's what I have. And then you have inside of build block, you have a lot of different parameters what you can do. Like you can specify pretty much all arguments which is supported by Docker. And that's really, to my mind, this is really impressive, that you have full control of your Docker image creation and how to push it to Docker registry is pretty big. So the only thing which is required here is just name and, well, quite obviously how to build it, where to build it from, context. So take a look into this provider, and if you want to contribute to this provider, I know that Manuel is looking for people who can support it. Yeah, don't hesitate to reach out to him or to these GitHub issues. There are 76 issues, but I'm quite sure that overall the quality is very good, and you can just you can just use it quite happily. Any other questions? Hopefully I answered your question about Docker container, but if not, please let me know. Well, related to this point is the fact that this Lambda module relies on Python is currently one of the stopping block for many people to use this module inside of automation like Terraform Cloud. If I have time or interest, or I don't know what has to happen, I can make this module to work on Terraform Cloud where Python is not pre-installed. Well, there are a few things how you can do this, but and I think it's even kind of not against anything like any terms of service, so it should be possible. But I just don't need this myself, because on other CI platforms I have pretty good control of what I want to install inside of that system. So yeah, that's if you have paid account in Terraform Cloud, you can install different things yourself, and yeah, it will just work. So that's it. Okay. Any other questions? No. Or yes. Or no. Okay. Anyway, thanks a lot, and see you next time. Bye.